computer that has one and only one job. It's not like your laptop that can browse the web and do spreadsheets and everything else. Nope. This little system is built to do one dedicated task and to do it perfectly. Think about it. Its job might be running your microwave, or something way more critical, like deploying an airbag in a car.
And when you look at this, you start to see just how surrounded we are by these things. They are the absolute unsung heroes of modern tech. Seriously, think about it. Your car has dozens of them. Your dishwasher has one. They're in absolutely everything, from life-saving medical gear to the Wi-Fi router in your house. These little dedicated brains are literally everywhere, just quietly running the world in the background.
Okay, so let's recap. We have billions of smart devices, they've all got these embedded brains, and they're all creating just mountains of data all the time. This creates a huge problem, right? It's like a massive data traffic jam. How in the world do you process all of that information instantly? Well, that brings us to the final piece of our puzzle, the tech that solves this exact problem: edge computing.
Here's a perfect way to think about it: a smart city. Imagine a self-driving car. It can't afford to wait for data to travel hundreds of miles away to some server and then wait for a response before it decides to hit the brakes. No way. That decision has to be instantaneous. And to do that, you need to process the information right there, on the spot, locally. And that right there is the genius of edge computing. It's a system that brings the number crunching, the processing, way closer to where the data actually comes from. So instead of sending every single piece of information on a long trip to a centralized cloud, it does all the heavy lifting right there, at the edge of the network, right where the action is happening.
This comparison really makes it click, doesn't it? The old way, centralized processing, that's like a long, slow journey for your data. But edge computing, the analysis happens right away, on the spot. It's really the difference between sending a letter in the mail and having a face-to-face, real-time conversation. One is slow, the other is instant.
So there we have it, our three key pieces of tech: the connected device, the dedicated brain, and that super-fast local processing. Now, let's put it all together. Let's finally solve that riddle from the beginning. Let's break down a smart car, for example. The car itself, that's the thing. It's an IoT device, connected to the network. Its brain? Well, that's actually a whole bunch of embedded systems, each one controlling something specific, from the engine to your music. And its speed, that split-second ability to react, that comes from edge computing, processing all that sensor data right then and there.
So here's the main takeaway, the most important thing to remember. IoT, embedded systems, and edge computing, they're not just separate ideas. They're layers. They build on top of each other. You've got the connected thing, its